Welcome to another video of Optatube. So, we all hear about renewable energy, right? It's the future, it's clean, the fuel is totally free, and honestly, it's what the planet needs. But behind that really simple, powerful idea, there's this massive engineering puzzle. Today, we're going to pull back the curtain and look at the hidden complexity of plugging the sun and the wind into a grid that was, well, built for a completely different kind of power.
And really, that's the million-dollar question, isn't it? If you're getting clean, free power from a solar panel or a wind turbine, why can't we just build millions of them and call it a day? Well, the answer really boils down to one single powerful challenge: control.
Okay, so before we dive into the tricky stuff, let's talk about the why. Let's start with the incredible promise, the whole reason we're even having this conversation. The benefits of renewables are so clear and compelling, and they're completely reshaping our energy world.
So, just so we're all on the same page, when we talk about renewable units in the context of the power grid, what do we actually mean? Well, we're talking about the main players in this new energy story. Massive wind farms capturing the power of the air, solar panels converting pure sunlight into electricity, and even smaller hydro plants using the flow of water. These are the heroes of our story.
All right, let's get into it. The upside here is just incredibly bright. You get clean, zero-emission power. That's huge. But from an economic point of view, here's the real game changer. The marginal cost is zero. The fuel, the sun, the wind, it's free. This means every single megawatt of renewable power we generate pushes a more expensive megawatt from, say, a coal or gas plant off the system. But, and you knew there was a but coming, that's only half the story. And here's where things get complicated. For all their amazing benefits, renewables introduce a total wild card into the power grid: the weather. And this brings us right to the heart of the engineering challenge for the modern grid operator. This all comes down to one really important word: non-dispatchable. Now, what does that mean? Well, think of a traditional power plant like a faucet. You need more power, you turn it up. You need less, you turn it down. Simple. Renewables? They're more like putting a bucket out in the rain. You can't control when it rains or how hard it rains. You just have to take what you get when you get it. And that lack of control, that's the entire problem right there.
Now, to be fair, it's not complete chaos. Grid operators are actually fantastic at forecasting the big picture. They know that solar power is going to have that predictable hump right in the middle of the day. They know the wind might kick up in the evenings or early mornings, so they can plan for these broad general cycles.
But this is the whole challenge in one picture. On the left, you've got the forecast, that nice, smooth, predictable curve. And on the right, that's reality. That jagged, spiky, unpredictable line is what operators actually have to deal with. A cloud floats over a huge solar farm, the wind suddenly dies down, and boom, the power output is jumping all over the place. Managing the gap between that smooth forecast and that messy reality is the real job, minute by minute. So you might be wondering, how on earth do they manage that? Well, this isn't magic, it's just brilliant engineering. Grid operators have a really sophisticated set of tools that use to handle all this uncertainty and, keep our lights on. You can think of it like a four-step dance that they're constantly doing. First, they use these incredibly advanced weather models to forecast what they think they'll get. Second, they schedule the traditional, controllable power plants around that forecast. Third, and this is absolutely key, they keep a buffer of backup power ready to go, called reserves. And finally, if all else fails, they have a last resort option called curtailment.
Now, to really get how they approach this, you've got to understand a core rule of the modern grid. Renewables are considered must-take. What that means is, because the fuel is free, the grid is basically designed to take every last clean electron it can get. It's the cheapest and greenest power, so you always use it first. But that rule creates its own headaches.
This is where the grid's insurance policy comes in. We call them system reserves. These are basically other power plants, usually flexible natural gas plants, that are kept idling on standby. So, if the wind suddenly stops blowing, these reserves can ramp up their power in seconds to fill that gap. They're like the shock absorbers for the entire system.
And it all boils down to a pretty simple relationship, which is exactly what this quote says. The more unpredictable energy you have, the more backup power you need to keep ready. You can think of it like an uncertainty tax. The more volatile and unpredictable your renewables are, the bigger that safety net of reserves has to be. And of course, keeping that safety net ready costs money.
And that leads us to one of the most bizarre, counterintuitive ideas in the whole energy world. Imagine a cool, sunny, windy spring day. Nobody's running their air conditioning, so demand for electricity is low. But the wind turbines and solar panels are going full blast. You actually get too much power on the grid. To keep the system from overloading and becoming unstable, operators have to do the unthinkable. They tell wind turbines to stop spinning. They are forced to throw away perfectly good, clean, free energy just to keep the lights on.
So what all this means is that these challenges are actually forcing our grid to evolve. This need to manage all this variability is driving some incredible innovation, and it's pushing us toward a grid that isn't just cleaner, but one that is fundamentally smarter and way more flexible.
All right, so let's just quickly run through the big takeaways here. First, renewables don't just add clean energy, they add uncertainty. Second, the grid treats them as must-take power, which is great, but that increases the need for backup reserves. This means that flexible resources, like big batteries or smart ways to manage demand, are absolutely critical for keeping everything in balance. And finally, sometimes throwing away clean energy through curtailment is a necessary evil to keep the system safe.
And this all leaves us with the big question for the next decade, doesn't it? We know how to make the grid cleaner. You just add more renewables. The real challenge now is building the smart, flexible, and resilient system that's required to support all of them. The solution isn't just about generating clean power anymore. It's about mastering it. And by the way, if you are interested in the energy market, power system modeling, and want more updates and insights about the global energy market, make sure you follow the Optatube YouTube channel.